Bot defense is a critical necessary part of any strategy for API security. After all, you can't spell API security without bot defense. Nowadays, APIs are everywhere. APIs are how modern apps and microservices communicate. And thanks to modernization efforts, APIs are also the windows into legacy monolithic apps. As the number of APIs grows, so too does the attack surface that APIs expose. OWASP has acknowledged the importance of this growing attack surface by releasing its API security project, which includes a list of the top 10 API security vulnerabilities. As we review these vulnerabilities, it's going to become clear how closely associated they are with bots. Number one on the list is broken authentication. How can an authentication system be broken? Two ways are that they allow for brute force attacks on usernames and password combinations, and they allow for credential stuffing. That's when criminals use breach credentials from one site to test against the logins of another, hoping that users have reused their credentials, as they unfortunately often do. Both brute force attacks and credential stuffing, because of the scale, require automation. So, automation implies bots. So to mitigate against broken authentication, you need bot defense. Unrestricted resource consumption occurs when APIs do not control the number of incoming requests, which can result in excessive costs, slow performance, and unavailability. Unrestricted resource consumption can quickly turn into a serious problem when bots go after an API that was designed for interactive applications, that is, web and mobile applications used by human beings. Generally, application usage tends to be predictable and resources can be allocated accordingly. But with bots, usage can spike suddenly without warning, exhausting the resources used to serve the API. So in this case, it's really bots that make the lack of controls on resource a serious threat. Unrestricted access to sensitive business flows. What does that mean? It means the automated exploitation of a business flow that was not intended to be automated. Let me give you a few examples. An attacker can use automation to buy all the stock of a high-demand item at once and resell for a higher price. We refer to this as unauthorized reselling, and it is why tickets to this Taylor Swift Eras Tour were sold out in seconds, causing much anger among her fans. An attacker can reserve all the available time slots and prevent others from using a system. We've seen this happen with hotels, whereby bots reserve rooms. While the room reservation may only be good for 15 minutes without a purchase, if bots continue to make the reservation throughout the day, all the rooms might remain permanently booked without anybody actually paying. The remaining 7 API vulnerabilities are all based on mistakes in implementation or configuration. Broken object level authorization is when an API mistakenly gives a user access to an object that they should not have access to, such as somebody else's medical record. Broken object property level authorization is when an API mistakenly gives a user access to too many properties of an object, such as exposing another user's credit card number rather than just their name. Broken function level authorization is when a function performs an operation that it should not, such as withdrawing money out of the wrong account. Improper inventory management, that's when you lose track of an API and forget that it requires access controls. Security misconfiguration, well, that's just another word for a mistake. Unsafe consumption of APIs, that is when one API consumes the resources of another API when it shouldn't, when that third-party API or other API internally is returning, for some reason, content that is malicious. Server-side request forgery is when a request to an API causes it to consume other resources that are not safe to consume, that cause malicious behavior. There are many tools out there available to penetration testers and adversaries alike that automate the process of finding these vulnerabilities. Here's a list of several such tools. Note, the logo you can't read is Kite Runner. By the way, Corey Bull's book, Hacking APIs, is a great way to learn how to use these tools for penetration testing. I highly recommend it. So how do you introduce bots into threat modeling for APIs? First of all, you should continuously engage in API endpoint discovery. You can't protect what you don't know about. When API endpoints are discovered, it's important to consider which ones are vulnerable to bots, which I'll address in a moment. Knowing which endpoints are vulnerable to bots, the question becomes whether they're adequately protected. As other demos in our booth make clear, older techniques such as capture and IP denial lists are no longer adequate in the face of advanced, sophisticated bots. There are several categories of API endpoints that are particularly vulnerable to bots. Login APIs are particularly critical targets of bots for credential stuffing and MFA bypass. Inventory and pricing APIs are vulnerable to scraping bots. They're extracting competitive data and putting a huge strain on infrastructure. Purchasing transaction APIs are vulnerable to bots that perform unauthorized reselling. And credit card verification APIs, vulnerable to carding, which leads to chargebacks and fines from credit card agencies. These are not the only vulnerable APIs. There could be others based on your applications. You really need to think through the business purpose of each API to consider it, how it might be exploited by bots. Thank you very much for your time today. Enjoy the conference.